Alright class, today we're going to look at different graphings of the square roots and cube root functions. First we're going to kind of remember the quadratic equation for a in vertex form is this, where the vertex is HK, and we're also going to look at absolute value, again where the vertex is HK. If A is greater than 1, either doesn't matter if it's negative or positive, it is stretched vertically, whereas it's compressed the other way. So remember that what I'm looking for is I need to see that the vertex is in the general location, the correct shape of the graph, and the stretch, normal, and compressed. Overdo it. What I like to do actually, and I want you guys to do, I want you to sketch the parent. So the parent for this would be just x squared. So the x squared is just a parabola, okay? And then you have to look at this, and you have to say, well, the new vertex is at 5, 3. So I'm going to go to 5, and it can just be kind of there. And then the negative sign flips it over, and actually it flipped over first. And then this means if A is bigger, it's stretching vertically. So if you told me it looked like this, you'd be correct. And I didn't have to graph it with my calculator. I just want you to know, or I want to see that you know what the difference is. Okay? Same thing with this one. This one has the absolute value of x is the parent. So if I do that, that looks like this. It's a V. So this is the basic original shape. Now 1/2 means it'll compress or flatten. In this case, it'll push it towards the axis, and then our vertex point is at -2, -4. So that's right here. It does not flip over because there's no negative sign, so this will look something like this. Notice how it's flattened out, okay? Alright, those are those two. Now we're going to do a few different graphs. X cubed, if you plug it into your calculator, you get the point 0, 0. When 1 happens, you're at 1, and when 2 happens, you're at 8. Okay? And then the same thing, when -1 happens, you're at -1, and when you're at -2, you're at -8, because -2 cubed is -8. So you get a graph that looks something like this. Okay? If you look at this, the domain is that x is all real numbers, because you can plug anything in. The range is also all real numbers for a cube function, because there's no restriction. You can have negatives and positives for your range. If you have a negative x cubed, it flips it over, so this stuff is now up here. So I'm going to graph this. It changes the y values. So it looks like that. So this is the negative x cubed. Okay. Now, I'm going to do the same thing we just did from the the quadratic and the absolute value, and we're going to do it with this. There's no change here, so that means the x coordinate of the new vertex is 0, -3. So I'm going to sketch the parent real fast. So that's my parent. Now this is important. This means it compresses vertically. So that means that these are going to flatten towards the axis, and then I'm starting at 0, -3. So 1, 2, 3. And if this is flattening down, the graph is now going to look like this, because it's pushing and flattening it closer to the axis. So that is what the final graph should look like. Alright, this last one, the parent again, is this. So I have something to compare it to. My vertex is now at 4, 1. So there it is. It is a negative, so it's flipping, so it's going to go in this direction over here, the one that the blue one is for number 3. And 6 means it's stretching vertically, so it's going to go up and down real quick. So it's going to barely move. It's going to go like that and like that. It's pulling it faster, so it's almost tightening it even more, that it's almost a line. Okay? And you can check these with your calculator if you need to. On the quiz, though, there will be a non-calculator part for these kind of questions. Alright, square roots are a little different because there are restrictions. The starting point for the square root is at HK. Instead of a vertex, it's actually where it starts. So the graph of y equals square root of x has the point 0, 0. When x is 1, y is 1. When x is 4, y is 2. And when x is 9, y is 3. Notice how there is a domain restriction because we have a root. X has to be greater than or equal to 0. And if you look, because of that, the range will have to also be greater than or equal to 0 based on this picture. It's only positive y values. Everything else is the same. You have to be careful though. Since this is sideways, when you stretch it, you actually end up pulling it upward. Okay, so let's see what happens. So, the starting point for this one is, well, I'm going to first of all draw the parent. So this is my parent. The starting point is at 2, negative 5, and then it stretches, which means it pulls it up. So it's a little different than all the other ones we were looking at where it made it kind of skinnier. This one's actually going to make it wider. So my point is at 2, negative 5, right here, and then it's pulling this, instead of going like this, it's pulling it more up. So it's pulling up more. The domain is that x is greater than or equal to 2. The range looks like it's greater than or equal to, it starts at negative 5. So these tell you where it starts, and then just look at which direction it's going, because sometimes it flips. And then when you do steps and how it's transforming, you always do the flip first, or the stretch. In this case, we're going to say it's stretched vertically by a factor of 3. Then it doesn't matter which move you do next, but generally it should be the horizontal move. So it moved 2 right, and it moved 5 down. So that'd be the steps you do. Always do the stretch and reflect first, because you don't want to say it reflects over the x-axis after the fact. Like this one here. Here's my parent function. The steps, we could say it, I'm going to just do that first before we even do it. Reflect over x-axis. 2, we're going to say that it compressed vertically by 1/2. 3, we're going to say it moves, if you look, that should be left 6. And then 4, it moves up 2. And now based on that, we know it's going to be flipped over and then moved, and it's going to be compressed. So if I move left 6, 1, 2, 3, 4, 5, 6, and up 2, I'm here. It's going downward, except for it's being pushed towards this line. It's being pushed towards its own point, so it's actually going to be skinnier. Okay, it's more compressed, pushed towards itself. The domain for this is x has to be greater than or equal to negative 6. The range is y is actually less than or equal to 2, because now the graph's going downward. Okay. So that is square root graphs. Now we are going to do cubed roots. Cubed roots are very similar to square roots, except for you can get negatives and positives, because we have the cube root of 0 is 0, the cube root of 1 is 1, the cube root of 8 is 2. The cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. So those are your base points to start. It's like a flipped or a sideways cubic function. Everything else is very similar. Again, when it stretches, it pulls the ends upward and downward, and when it compresses, it pushes them towards the x-axis or wherever you've moved it to. But notice how the domain is all real numbers, and the range is are all real numbers as well for the values. Okay, so this one we're going to do the same thing. Again, we can do the steps first. I see a negative, so I reflect over the x-axis. 2, I have a move right 2. And then 3, I have a move up 1. Okay, the parent, I'll just sketch real quick. Now it's reflecting and moving. It is not stretching or compressing, so it's going to kind of have that same width. So I'm moving it right 2, 1, 2, up 1 right here. So that's my new point, and it's reflecting. So, oh, it's actually going to be a graph. All right, so that would be it right there. The domain again is x is all real numbers because that doesn't change, and neither does the range. It's still going up and down forever. There are no asymptotes. All right, last one. I noticed that there's a stretch, a vertical stretch. Two, I noticed that there's a move left by 2. And 3, I noticed there's a move down 3. So again, I will sketch the parent. The parent looks like this. Something like that. Okay. I'm moving the point 2 to the left and 3 down. 1, 2, 3. So that's the starting point. And then because it is being stretched upward, this is going to go up faster. So it's going to look like this instead of that. It's very exaggerated, but all the y values are getting bigger faster. The domain is still all real numbers, and the range is still all real numbers. Okay, so that's how you do quick graphs. Again, for right now, if you're not comfortable with them yet, you can plug them in and look at them. But notice how all the moves are the same. The only thing that's kind of really different is this square root one, because you only have half a graph. It starts at a point and goes forward. All right, and then your quiz is in 2 days. We have a review day tomorrow.